So we're going to look into some ransomware. There are lots of ransomware all over the world now. We have lots of a big database of ransomware. If you haven't heard of WannaCry, this is not it. This is a different one. I'm not gonna. Maybe next year I'll talk about WannaCry. Okay, we're going to talk about Petya. If you heard about Petya, Petya is one of the ransomware that actually infects your master boot record. In this talk, we're going to look into how we can actually see some of the tools that I use in doing this research in order for you to actually follow up with this, and then you can do your own research. And another new thing on this one is I will show you how to debug a master boot record. Or probably you can make your own kernel in the master boot. Okay, about me, I work at Fortinet. Okay, we're not a sponsor. I publish some of the articles in Mbr Bulletin about malware research and everything, and of course, regular contributor in Fortinet, blog.fortinet.com. Those are some of my conferences that I've been to. Most of the time when I send my profile pic in a conference, it looks something like this. I always use this joke. But actually, deep inside, whenever I do malware research, that's me. It's supposed to be Batman, but it changed. Okay, trivia. Before we talk about master boot record, let's talk about some of the small facts that probably you didn't know. Okay, when I was still in university, we love to use this. Those are floppy disks, right? But this one, it only holds like a few megabytes. Probably one of your MP4 is probably won't fit in one of the disks. And look, hey, it died. Looking at the other side, there is an IBM 75 pounds, 1 gigabytes of data. You can put lots of music there, 1 gigabytes of data. But the problem is you cannot put it in your keychain because it's probably too huge. And now we can actually have 1 terabyte of data in one of the drive, which is 1020. Imagine bringing that to your work or having that in your home. Probably you won't have enough space to have 1024 of this one, 75 pounds. And looking at this, okay, it is equivalent to 256 of that particular device. And that's for the trivia one. Okay, every hard drive, if you want to make it as bootable, you should be able to see that the very first sector is actually what we call the master boot record. Or if it is just a regular disk, the floppy disk, you only call it the boot sector. Master boot record just came in when we were using the hard drive. Okay, I can actually see here. Okay, usually the very first sector, we call it the track 0, head 0, sector 1. Okay, and then for hard disk, we have the master boot record, and then from different partitions, we have actually different boot sectors if you want to make some of the partitions bootable. You can actually make different bootable partitions, okay, and then you can read those information in the sector 1, which is the master boot record. Okay, there's now actually a new version of how you make, because master boot record is, the Mbr style partitioning is, you only have 4, okay, you can only have 4 partitions, okay, and then if you want to have more partitions, you have to use one of the primary partition, make it as logical partitions, okay, but for GPT, they introduced the GPT GUID partition table, wherein you can use the UEFI. Those are the new technologies that we use. Okay, there's some sort of small software first to analyze which partition should be loaded and everything. Okay, but looking at those different styles of partitioning, okay, we have the Mbr style and the GPT. Both of them has the master boot record, right? But this one, okay, for backward compatibility, they still have the master boot record, and then they call it protective, but nobody's protecting it actually, just for a sort of putting it in backward compatibility. Okay, using a tool, this management, it is actually, you can get it from Microsoft itself. You can actually create your drive. You can actually create partitions based on what you want. You can create a GPT style, or you can create an Mbr style. Okay, but take note, you can only, it depends on what you want, how many partitions you want it to be primary, and so on and so forth. Okay, or if you already have those partitions and you want to change it, using the same tool, the disk management, you can actually change your Mbr to GPT or convert your GPT to Mbr. Let's go now to creating these partitions. For creating the disk partitions, as we all know that, okay, look at the first hard drive, this one, you only have 4 primary partitions. This is considered as now the extended logical, okay? But for the GPT style, you can load as many as you want, unlimited number of partitions. Of course, it depends on if you have so much number of partitions. If you have lots of partitions, each partition now is getting smaller and smaller. So, and most likely it will slow down your hard drive, the access time and everything. Okay, you can actually use one of the tool in Windows again, use the disk part. You can check right away if your hard drive is, if the hard drive installed in the machine is a GPT or not. Okay, just run the disk part, and then you can actually see that if there's an asterisk, that means it is a GPT. Okay, that's just you can automate this by using the actual command line. Let's go now to what are the different partitions. There are different terms that we use usually. For Mbr, we call it the CHS, the cylinder head sector addressing. Okay, but again, they have both master boot record. For the GPT, okay, instead of calling it CHS, they call it LBA. So LBA 0, LBA 1, those are per sectors. Per computation, okay, for example, LBA 0 is actually 001 CHS, and so on and so forth. We have 1, 002. Okay, take note that CHS didn't start with 000. I don't know why, but that's how it is, right? Okay, let's go now to the actual malware. Petya is, as I've said earlier, that it is actually encrypting. Most of the ransomware, they actually go to your machine, encrypt your files, and then that's it. But Petya is actually not encrypting your individual files. We'll see that later when we do the walkthrough. Okay, Petya is actually infecting the Mbr. Okay, these are the execution flow. Okay, at first, when you run the Petya, it will actually run those different passes just to decrypt. Okay, every time you pass this set of codes, okay, it is just actually decrypting the word only 4 bytes. Okay, if you're trying to analyze this malware, it will take you probably a lot of times just to see the decryption code. But you can always break point on at the end and then press F9 or run if you're using the OLEDBG or Immunity Debugger. Okay, it checks first if the decrypted code, if you already have decrypted everything, it checks if it is decrypted code. Of course, checking for the MZ, header, the PE, if they are, just to make sure that it is decrypting the actual malware code. After that, okay, it tries to resolve normal malware, or not we cannot say normal malware, regular malware, not normal, okay? So we can actually, most of the malware that you will encounter is, they normally get this get proc address, load library, and virtual alloc. Sometimes they are using hashes in order for it to be able to decrypt. Then once they get the addresses or those APIs, it can now proceed on getting the rest of the APIs that it needs, the application programming interface, right? So this is how it works. It has a list of strings of the API names, okay, and then it runs those 3 sets of API that it has hashed earlier, and then it gets all the rest, the remaining APIs that it needs. And then within that malware code, okay, it is now looking for the XXXX section, okay, if that malware, if that binary doesn't have that, that means it is not the petya itself. Okay, but looking at that, it is actually getting that, and then it is still, again, it already the decrypted portion, but now it is in its form, it is still encrypted. Okay, if you want to get that part, okay, it will run this particular code, and afterwards you will be able to get this one. You can actually see the messages that it will use later on. Okay, and this particular sets of characters, it is actually scary later. No, not actually scary. Probably scary for regular users. Okay, the bootable disk. Okay, in order to actually write, okay, when the malware actually go to infect your MBR, it actually have to look for the bootable disk. Okay, the way it uses it is it actually use a regular API create file A, and then use the device IO control API. Okay, the device IO control API, it has different sets of codes. Okay, to get the logical drive 0, okay, it just assumes that the very first drive is the logical drive 0 or the primary drive. Okay, this is some of the format that it uses. Okay, to open a physical logical drive and then use it for file share and this one. For the initial execution, actually, it just checks the malware. When the initial execution of the malware, it checks if your physical drive or drive 0 is actually accessible. If it is not, it will just go away. Okay, the initial call for the device IO control. Okay, this is the MSDN version of, if you search, usually if you want to do malware research and then you encounter a new API, just go online or look for MSDN, it will give you the different information. So for device IO control API, we only need this two information, and then this one will give you exactly what the malware does. For the first call for the device IO control, it just wants to know if the drive C or your first drive is accessible. Okay, it uses the IOCTL volume get volume this extends, and then afterwards, when it executes or it can access that drive, that means it will now proceed on the infection. So we are still on the binary, the user tree level code. Okay, once it knows that it is actually can access your device, okay, it will now proceed on the infection. Physical drive 0 is actually another form of drive C, or your first drive. In different Windows disk class, it is also called device hard disk DR0, DR1. Okay, for backward compatibility, for Windows NT4, it is also called device hard disk, almost similar with the other one, but it is now with hard disk 0 and partition 0. So if you're reading an article or something, reading a book, it wants to access those things, or it mentions those information, it is actually calling just the drive 0. Okay? Legacy names, you can see it, global, physical drive, and so on and so forth. But if you want to really access this particular drive or the drive C, you can just use the create file A and then physical drive, and then that's it. You will be able to access your hard disk. Okay? This is a very complicated way of telling people not to infect the malware, but at the same time, or not to infect your hard drive, but at the same time, this is the only way you can show how it is being done, right? I'm not telling you to infect your MBR or infect others' MBR, but I just want to show how I did the research. Using WinOBJ, it comes from sysinternals. It is another tool wherein you can actually grab the information or just run it, and then it will tell you what are the drives that is inside your machine. Okay? WinOBJ. Okay, we have the global, and then the hard drive. It's just a random information that you can actually use. Okay, for the physical drive, okay, there is a portion of the code wherein it gets your physical drive 0, and then use the device IO control in order for you to be able to access the drive. Okay, IO control code 7043 is actually getting the this partition information. Okay? So it gets this particular part. Okay, those are the buffers that when it runs the API, it will get those data. And this is the another information it gets. It actually tells you, okay, the Petya actually wants to know if you're using Mbr, GPT, or just a regular row partition. But actually, it doesn't care. It will just infect. Okay, using process monitor, it is another tool from sysinternal. If you don't want to go deeper on the actual code, you can just run process monitor. You can actually see if something is happening in your drive. Okay? If you see that create file and combination of create file and device IO control is trying to access hard disk 0, DR0, and then looking at this, looking for that kind of partition, that means, okay, this is process monitor. That means something or some normal application normally doesn't touch that, but it actually accesses that. If you see that some malware or some application is trying to access that, it's either trying to infect your Mbr. It is now the process of reading and getting your information from the Mbr. First, it reads a copy of your Mbr, okay, and a series of instructions wherein it reads from sector 1 up to sector 21 hex, the hex bytes. Okay, it opens it, XOR it with 37. It's just a simple XOR actually, but it is very effective. If you can actually create a tool that will clean your Mbr, okay, and then create file, and then once it reads first the sector, XOR the content, and writes it back. Okay, that means it is now slowly encrypting your Mbr, and soon you will not be able to use your machine. And then after doing this, okay, it is now going to use the new Mbr. It is going to overwrite the original Mbr. And then afterward, there is a kernel code, okay, a small kernel code wherein it tries starting at 22. Okay, kernel code, that means it will run when you reset your machine. Okay, if you want to know more on the different information within the Mbr, most of the time, okay, if your sector has this marker, there is a boot sector marker. So you can actually read your sector, and then you can find out if it is bootable. Okay, and then for this one, the Mbr Start, there is actually 4. This is the 4 partition wherein it contains data for your different partition. Okay, this is the code wherein it looks for your Mbr, K55AA, and then it actually tries to get that. That's the first one. It reads the Mbr contents. And then this is another tool. Okay, you can actually download this somewhere, but make sure that it's clean. I'm not gonna give you the link, okay, because I might give you the wrong link. It's up to you to download. But this one is actually, you can actually use this to overwrite or to read your Mbr or your any sector in that particular model. You just have to show which, or you have to select which partition, and then how many sectors, if you want to read the Mbr, or how many sectors that you want to read, and so on and so forth. You can read them or save them to a file. Okay? You can actually write sector on this. You read the file, your Mbr, you modify it, put it back in your Mbr, and then you're dead. You might have corrupted your machine already. Don't do that at home. You can go to your neighbors, try it, and then it's probably gonna work. Okay? Okay, using the hacker tool, this is the one that it writes to the file. Okay, and from Petya, it's actually, from malware code, it is actually this one. You're going to see this. It is already read the whole thing, your initial Mbr to somewhere in the malware code. Okay, again, following the read, encrypt, and overwrite, okay, this is the part where it XORs it to 37. And then this is the part where it reads the particular Mbr sector. This is the one that reads it. You can see them in the actual malware code. And then if you want to follow them using the tool, the HD hacker, all you have to do is to specify which sector, and then you will see that this number 7, it is actually 0x37 is actually an ASCII code for 7, right? Right. Okay, this is the one. If you want to use process monitor, you can actually see. Okay, now you have more information. You have now more evidence that somebody is trying to overwrite your hard drive. Okay, but by this time, if you say this, you are probably already too late. Okay, you won't be able to see this. But actually, since the thing is, how come it can overwrite your hard drive, but the machine is still working? How come I can still see this one, right? Because while the malware is writing code or overwriting your sectors, okay, it is not actually executing it, not yet. But you have to reset the whole thing in order for you to see the execution. Okay, we're going to follow that later. This is again the writing. This is now the new Mbr. You can see that the initial Mbr, the regular Mbr that you can see from your machine is actually, you can see actually some of the strings. But now, the new Mbr contains this. It only contains one partition information, wherein that is actually the bootable sector. Okay? It's actually a huge stage. Okay, then the new Mbr, this is the new Mbr written. Okay, once the new Mbr sector, the first sector was overwritten, even if you have the Mbr style or the GPT, they are now both infected. Okay, it doesn't matter if you are using Mbr, it doesn't matter if you're using GPT, you will still be infected. But later on, I will tell you how to stop the infection, or how to prevent the infection, if I remember to tell you. Okay, this is now the writing of the sectors. This is where it writes the actual kernel code. Okay, starting at sector 0x22, okay, using the process monitor, it doesn't say 0x22, 4400. Each sector is actually how big? It's actually 0x200. Okay, so multiply that with 22, you will be able to get this, and then it writes the kernel is actually 16 sector big. Okay, once the sector is overwritten, okay, you can actually follow this malware code or the malware, the petya. Okay, you can actually get the actual kernel code, and then you can modify it all you want. But I'm not saying modify it. I'm not saying to make your own. Okay. You didn't hear it from me. I think it's not recorded. Okay, this is what you can see when the sector is already loaded. This is part of the kernel code of the malware. Okay, it is now written in your hard drive. Okay, you can see this. Some of them are actually information about it wants to get your payment through Bitcoin and so on and so forth. Okay. Okay, it even has the Tor information. I put asterisk on that so that you don't need to follow them. Okay, no need to trace. Okay, you can use HD hacker again to see the content of the names of the Tor information. And then now it will reboot once. I already have 15 minutes. I still have more. Okay, once it reboots the system to activate the payload, I have to go fast. Okay, burst, before it activates the payload, it needs to escalate the privilege. Okay, it first gets the current process. These are the APIs that if you combine them, okay, these are not malicious by itself, but if you combine them, you can now escalate your privilege. Escalate meaning if you're a regular user, you can escalate it to admin user. Okay, once it is escalated, you can now run the hard reboot. This is an API wherein you execute this, it will reset the computer. So the malware, Petya, doesn't want to wait for you to reset your machine. Once it infects your machine, it will reboot by itself. So when you're analyzing or when you see that it is writing somewhere in your hard drive, okay, and then it reboots, it's probably the Petya ransomware. Okay? And now we're going to the payload in the debugger. Okay, for the debugger, have you heard of BOCHS box? It is actually an emulator wherein it simulates Intel x86 computer. You can run actually games using this one, old games, because it probably won't work on your Windows system. Okay, you can use it to debug Mbr code. And then when I tried it on my machine, I have to step 5 million times in order to reach 7C00. 7C00 contains the initial code of the Mbr or the boot sector. Okay, and then once it reaches 0x7C00, it will now start the new petya. It will now check, okay, the Mbr is actually executed in 0x7C00. Okay, whatever is inside that code, it will be executed. This is now the debugger, the Bosch, I don't know how to say it, the Bosch debugger. Okay, the problem with that, it is unlike your regular OLE debug. It is not very user-friendly, okay? You have to refresh every time you want to see it. You have to refresh this window, the debug window, to see the code, and so on and so forth, okay? Every time you do something, you have to refresh. The problem with debugging an Mbr is you cannot actually use an API. So it uses regular interrupts and functions, regular DOS information, regular DOS functions, okay? Let's go now to C. This one is actually information wherein it is now going to read your sector. Okay, these are the information. This is the memory buffer wherein it puts everything from that sector. Okay, this is the size of this address packet, and this particular information is the petya code wherein it needs those information to read your Mbr. Okay. And then it uses interrupt 13, function 42 to read the information. I'm just doing it really fast because. So this one is actually the initial code, 7C2C. It jumps here, jumps to the original, to the malware in the 800 address. And then the problem with the debugging the Mbr is, as I've said earlier, that you have to constantly refresh the code window, okay? Okay, it initializes the screen first, okay? It copies the contents of the Mbr, okay? These are the code sectors. Probably you will just see it when they post it online. This is the content of the actual code in the Bosch. Remember that we are in the debugger, right? And this is the marker. This particular marker is the one that tells you that if it is encrypted or not, okay? I have this initial video wherein it tells you how it runs. So the Bosch emulator will give you a standard screen, okay? It will execute this interrupt 10 wherein it actually just output letter bytes per bytes, okay? And if you are familiar with fdisk is a tool in Windows wherein it tries to check if your system has a problem. So petya uses the same information or the same text, the same strings, and for you to think that it's just doing some checking. It is actually trying to start to infect your machine. Okay? It knows that you are using NTFS. Actually, it is actually just a string in the malware itself. Once it is done on the screen display, see, it will look like a regular system checking, right? But you're actually, at this point, you are not yet infected. If you can see that one, okay, you can actually restart the machine, try to find your malware. But this one, the next one will be so if you see this, you're not yet infected. It's just displaying some screen. Okay, but the next one, okay, it is now going to read your malware and so on and so forth. This is the Let's go back to this one. It reads your malware, it marks the particular byte 401. That means it is now going to start your encryption. Okay? It writes the contents to sector 36 and so on and so forth. That is the initial marking. Okay? And then afterwards, it is now going to infect your system. It is now checking if you have, it goes to the active partition. This is how it checks. It looks for the NTFS marker. Okay? After that, once it locates the boot sector, it is now going to locate the contents of the MFT. MFT is the master file table wherein every file in your system has an entry. Okay? If you destroy the MFT, it doesn't matter if your file is actually encrypted or not. You will not be able to see them. Okay? So that's what the Petya malware did. It actually just encrypted the entry, not the actual file. So it is kind of different from your regular ransomware. See, you have a regular ransomware now. Okay, it reads for 2 sectors for encryption. Okay, and then it displays the initial counter. Okay, the initial counter now, it says, check this is repairing, or not F this earlier, it said F this. Check this is repairing sector 2. Once you see, check this is repairing sector 2, that means it is already encrypted that sector. You're now too late. It is now going to encrypt your malware. The MFT information, initially it will look something like this. You have file, and you have everything there. And then once it is infected, it will look like this. And then that's it. The infection will start. Okay, actually the counter, okay, we're in op and numbers. That's actually the number of sectors that contains your malware. This is now the infection routine. Okay, it calls that particular function. Some of the functions that it needs, sometimes it just displays the string for the counter, and then while it is displaying the counter, it is actually infecting your machine. The problem is, if you're planning to clean your system, okay, you have to wait for the malware to finish everything. Because if it stops in the middle and you were able to find a cure for the system, okay, in the middle of it, if it is not yet encrypted, you will actually the one encrypting your disk. So you have to wait for the malware to finish. Sometimes you have to compromise, right? You have to wait for the malware to finish, and then that's it. Okay, it will call that infection. Did I show you that? So that is the regular sector. And then it's out. I just fast forwarded it. Okay, the 32,320 is actually the number of sectors wherein it contains the MFT entries. And then it will take you a long time to do that. So do not stop the malware in that portion, because you will just corrupt the whole thing. But the main solution is actually you should have backup on everything, right? And then another code will be triggered to restart. Okay. Earlier, we have a hard reboot. Now it is now bootstrap interrupt 19 is actually going to execute the reboot. It will reboot the second time, okay, to show you that it is actually, you are actually encrypted. At first, it actually initializes the screen, and this is the one. Okay, once you see this, you're actually, the encryption for the MFT is actually done. This one is only just a display, and then after the display, it will ask you for your Bitcoin payment, for ransomware payment, and then of course, if it gives you the whole thing, so it changes the red. If you pay, it is not actually guaranteed that you will have your hard drive back, right? Okay. If you've seen this is actually, so this one, once you show this screen, that means it is actually your hard drive is already infected. Remember that. Okay, press any key. If you didn't press any key, it will somehow do some blinking. Come on, do some blinking. You should do some blinking, that one. If you're not scared on the initial page, it will try to scare you more, right? The only problem is, if you're infected with Petya, unlike other ransomware, when you're infected, you can actually go online, pay your payment using that. But this one, if you're infected with Petya, there's no way for you to go back to the screen. You have to use another computer to pay, and then get that code to put it back here. Okay? You will go to, it will tell you to go to the, again, I blurred it. You have to go to that part, you have to pay, and then you will be able to get the, supposed to be, you will be able to get the key. And then I try to trick the malware, putting some keys. It's not working. Incorrect key, please try again. Okay, because I'm debugging the malware, I actually trying to trick it to get the code, okay? So trying to use Bosch again, trying to put my information, okay, still not working. I tried my name, it actually works. Look. Still reading it. Oops, almost there. See? You can use my name. It will decrypt the pen. I didn't do the malware, but it actually works. No, actually it didn't. I just skipped somewhere, go on the decryption routine. Actually, the encryption and the decryption routine is the same. And then once it thought that actually you were able to decrypt, okay, it will ask you now. It is not the one rebooting the system. It is now asking you to reboot your computer. Okay, since I don't have that much time, okay, just for wrap up, okay, Petya stage 1, you're running the malware. Okay, it copies the Mbr, mini kernel code, and then reboot. Okay, on the stage 2, you are now running in your kernel, in your Mbr. Okay, displays the fdisk, encrypts your MFT, initiates the second reboot, and waits for your, of course, the scary part, the ASCII skull, waits for your Bitcoin. Actually, that is the red Petya. There's already the green Petya if you're following its career. Okay, there's a green Petya. There's actually another version of that. Okay, I forgot the name. I think orange. No, it's not orange. And then the tools that I use, you can actually go back to the slides. You can try to grab the malware, but be sure that you won't run it in your machine. Always go to your neighbors. Try that, and then you can use the tools that I've mentioned, and you would be probably. It is not only useful for Petya. It is useful for a malware that tries to infect your hard drive, and so on. I think that's it.